Okay, so this week we're doing continuous and non-continuous functions. This is problem number 15 from page 239, roughly. My sketch may look a little different, but that's the problem I'm attempting to represent here. So, the important thing with this problem, you're trying to determine the domain of this function. So, again, this is similar to what we were doing last week in looking at graphs. What you're primarily going to be focused on is what are the possible values for x in this graph. So you're essentially going to look for what I call holes in the graph, where there are no y values for the corresponding x values. So for this graph in particular, we've got what would be normally a straight line, but right here there's a hole at where x, it doesn't matter what the y value is, but it's at where x equals 3. So this graph is continuous for everything below 3 and all the x values above 3, but it doesn't exist at 3. So you're going to write, there's a couple of ways that you could do this. You just want to make sure that you signify that x could be all possible values except 3. If you're going to use set builder notation, that would be from negative infinity up to 3. You use an open parentheses because the 3 is not included. And then that would be union, the u, with everything from 3, again, open parentheses, all the way to infinity. So that's one way you could do it. You could also write it out in words, which would be x is, oops, that's supposed to be an s, is all real numbers. Oops, I can spell, I promise. Even though I'm a math teacher, I do know how to spell real. I guess I was trying to start to write really. Oh, we'll just start that word over. Alright, so x is all real numbers. And again, you could write except 3 or x does not equal 3, something like that. You just need to make sure that it's clear to me that x can be anything but 3. Okay? If you have any questions on this, please let me know. Again, what you're going to be focusing on this is looking for values on the graph where x does not have a corresponding y value.